Hello everyone, and welcome to this tutorial on edeX 3 Xiera software, which is capable of automatically tuning fuzzy logic controllers. Now, this is a model-based tuner, which means that we do need a dynamical model of the process in order to move forward. If you already have a dynamical model of your process, you can move on to the next module where we'll show you how to build it into edeX 3. If, however, you don't already have a dynamical model, then this module will show how to obtain that model. The very first thing we need to do is data acquisition, and for that, Xiera also has a hardware called edeX hardware, which is meant to work in tandem with edeX software in order to obtain the data and model the process. If you have a third party for the hardware side that you're using to do the data acquisition, you can do that independently and consult the relevant manuals to be able to do that using the third party. Now, as far as Xiera's hardware is concerned, we have the XCM here, which contains the microcontroller and a USB connection to connect to the software, and a TTL here, which is going to connect the control module here, Xiera's control module, that's what XCM stands for, to the evaluation board. The evaluation board is what's going to house the input and output modules. We support various input and output modules like 0 to 10 volts, 4 to 20 milliamps, various thermocouple inputs, PWM, and more. You can see on our website a full list of the input and output modules that we support. Now, for the purposes of this tutorial, we have a demonstration set up in order to show the fuzzy controller development. Here we have the edeX hardware, which is of course connected to edeX software. Here you can see the PC. We have a power supply here connected to the motor driver. This motor driver, of course, drives this motor. This motor driver takes a 0 to 10 volt signal from an external controller. That 0 to 10 volt signal is going to be generated by this 0 to 10 volt output module on the evaluation board. The motor driver will then generate a feedback signal in frequency. That will go to this signal conditioner, which will convert it from frequency back into 0 to 10 volts into this input module on the evaluation board. We also have a potentiometer here, which is going to be used in order to generate the set point for the motor controller later on. And lastly, we have here a bike brake, which we're going to use to press on the motor in order to see how the fuzzy controller is going to respond to some load or disturbances and what have you. Now that we've gotten familiar with the setup, we can go ahead with the data acquisition. So here we're going to go to Target Hardware, Configuration and Texting, and we're going to click there. Now, before we connect to Target, we're going to make sure that our target type is correct, meaning that it's the XCM and the EVB together. And we're also going to make sure that the serial port is the one that the XCM is connected to. You can vary it here. So I'm going to connect, and I've successfully connected. Now we go to data acquisition, and here you can see that the EVB, or rather edeX software, will automatically detect what the inputs and the outputs are. You can also, for example, if you have none here by default, you'll also be able to select them from a drop-down menu. For the sampling interval for this experiment, we'll go with, say, 50 milliseconds. And then we will go to Run Data Acquisition. Now, we're going to set up our data logging, and here we will call this file, let's just say tutorial data 1. Okay. And we're going to click OK. And we are going to now start the data acquisition. And here we can vary the signal that we're sending to the motor driver. And you can see now Okay, and that should be good. So with that, we have completed the data acquisition, and we're just going to now show you the plot now to see what does our data look like. So what we're going to do is go to our sources here and go to data import, and we are going to find the tutorial data that we just took. Here it'll tell you the number of rows and the number of columns and so on. In order to know which to put as the time column and what to put as the imported columns, we need to look at our data file here. To the far left, this always just numbers the number of rows there are. The next one will usually be the time column. So we know here that the time column here is going to be number 2. And then here we can see, for example, in the beginning, this is definitely the last one is going to be the 0 to 10 volt signal to the motor driver, and then this is going to be the feedback. So we're going to go like that, and then we are going to plot this so that we can see what our data looks like. Before we do that, we do need to configure the simulation to make sure it's running at the time step that we want. And the duration should be, well, let's go back to our data file to see how long we ran the data acquisition for. Let's say 68 seconds. And here we're going to run the simulation, and we can see now our plot very nicely. We can see here this is the input that we gave to the process, and this over here in black is going to be the response of the process. And so next we're going to try to model the process.